So this is lecture number 2 and we are going to attempt past paper questions of AP chemistry, moles and molar mass. So first of all, this is a question: how many moles of ethane are there in 5.3 gram of ethane? So what we are given with the mass of ethane. So first of all, we need to find the moles. So for moles, the formula is moles is equal to mass divided by molar mass. So simply mass is 5.3 grams and the molar mass of C2H6 is carbon is 2 here and molar mass of carbon is 12.01 plus there are 6 hydrogens, so I am going to multiply it with 1.008, which is the molar mass of hydrogen, and the answer comes out to be 1.8 times 10 raised to power minus 1 moles. So correct answer is A. So let's move towards the next question, which is we have to find the molar mass of ammonium sulfate. So it's quite simple. We just need to find the molar mass of ammonium sulfate, and for that purpose I'm going to find out, like, I'm multiplying this 2 here, and molar mass of nitrogen is 14.01 plus there are 4 hydrogen, so 4 times 1.008 bracket closed. Now what is sulfur? Sulfur is 32.06, its molar mass. We are finding this molar mass from the periodic table, and there are 4 oxygen atoms, so I'm multiplying 4 with 16. 16 is the molar mass for oxygen. So the final answer comes out to be 132.144. So the correct answer is B. So in the next question, we have to find the mass of one atom of calcium. So here they have given us the number of atoms. So you remember the formula, which is number of particles is equal to mole times Avogadro's number. So here what they have given us, they have given us the number of particles, which is atom here. Particles can be atom, can be molecule, or can be ion. So here they have given us the number of particle, which is an atom, and they have given us 1 mole. We need to find out times Avogadro's number, so it comes out to be 10 raised to power 23, and mole is equal to 1 by 6.02 times 10 raised to power 23. And in order to find the mass, the formula we are going to use, mole is equal to mass over molar mass. And in order to find the mass here, so we are going to multiply mole with the molar mass. Mole is 1 by 6.02 times 10 raised to power 23, and molar mass of calcium is going to be 40.08. So answer comes out to be 6.66 times 10 raised to power minus 23 grams. So the right answer is going to be B there. In the next question, they want us to find the atoms of iron in 1 mole of Fe2O3. So in order to find the number of iron atom, just remember, in iron oxide it contains 2 atoms of Fe. There are 2 atoms of iron in it. So what we are going to do, we are going to use the formula number of atoms, which is equal to mole. Mole is only 1 here, times Avogadro's number. And now as there are 2 iron atoms, as we are finding iron atoms here, and there are 2 iron atoms, so I'm going to multiply this with 2 here. Okay, So final answer comes out to be 1.204 times 10 raised to power 23. So the correct answer is going to be C here. So in this question, they ask us to find how many molecules of propane does a 23.0 gram sample of propane contains. So first of all, they have given us the mass. So first we need to find the moles. So in order to find the moles, what we need to do, moles is equal to mass divided by molar mass. This is the formula we are going to use, and mass is 23 gram, and molar mass of propane is going to be, carbon is 3 here. 3 times the molar mass of carbon is 12.01 plus hydrogen. There are 8 hydrogen, and I'm multiplying it with 1.008, which is the molar mass of hydrogen, and the answer comes out to be uh, that is going to be 3.14 times so the answer is like 23 divided by 44.094, and 23 divided by 44.094, that comes out to be 0.5216. These are the moles, and in order to find the number of molecules, what we are going to do, simply mole times Avogadro's number, and that comes out to be, mole is how much, 0.5216, and times Avogadro's number, which is 6.02 times 10 raised to power 23, and the answer comes out to be 3.14 times 10 raised to power 23. So the right answer is going to be D there. In the next question, they have given us the mass, and we need to find out the greatest number of moles. So we need to find the moles of each one of them. And for that purpose, first we can do it for methanol. So it is going to be mole is equal to mass over molar mass. Molar mass of CH2O is going to be 30.026, and it comes out to be 0.03330. And for carbon dioxide, moles is equal to 1 mass is 2 here. 2 divided by the molar mass of carbon dioxide is 44.01, and that comes out to be 0.04544. And for S6, mole is equal to, mass is 3 here, and molar mass is going to be 192.36, and it comes out to be 0.01557. Okay, now after that we need to find the moles of this bromine, which has a mass of 4 gram, and 159.80 is the molar mass of Br2, and that comes out to be 0.02503. So greatest number of moles is basically for this, that is for carbon dioxide. So B is the right answer. After that, we need to find the moles, and we are given with the number of atoms there, and number of atoms are 860. So what we are going to do, I'm going to use number of particles is equal to mole times Avogadro's number, and mole is equal to, number of particles here are 860. 860 divided by 6.02 times 10 raised to power 23, and mole is equal to that is 1.43 times 10 raised to power minus 21. So right answer is going to be B there. Then we are given with the number of particles of chlorine which are 8.54 times 10 raised to power 20, and we need to find the mass of it. So for that purpose, we know the formula number of particles is equal to mole times Avogadro's number, and mole is going to be number of particles are 8.54 times 10 raised to power 20. Avogadro's comes at bottom, and moles comes out to be we can find the moles here. The moles will come out to be 8.54 divided by 6.02, and that comes out to be 1.41 times 10 raised to power 20 minus 23, that is going to become minus 3. Now we have to find the mass, and formula is going to be mass is equal to mole times molar mass. Mole is 1.41 times 10 raised to power minus 3, and molar mass is going to be 40 no, for chlorine is Cl2, so it is going to be 70.9. So the answer that comes out to be yes, so answer comes out to be that should be 2.00 times 10 raised to power minus 5. Okay, so the correct answer is going to be B. Now moving towards the next question, each of the following sample contains the same number of molecules and is stored at identical temperature and pressure. So they want us to find the greatest number of mass. So we are given with the number of molecules and they are same for everyone. So first of all, we can find the moles. And how can we find the moles of each one of them? Let's see. So in fact we are given with the number of molecules. So first let's find the number of moles. We know the formula is number of molecules, basically they are the number of particle, which is equal to mole times Avogadro's number. So mole is equal to number of molecules are how much? That is 1.204 times 10 raised to power 23 divided by Avogadro's number, and that comes out to be 0.2 moles. So in fact number of moles are same for everyone. We just need to find the mass of each one of them, and for that purpose we just need to multiply moles with the molar mass of each one of them. So like for carbon monoxide, the molar mass is going to be 28.01, and if I want to find the mass of this one, so I am to multiply with the molar mass of ammonia, which is going to be 17.034, and then we have to find the mass of CH4, so I'm multiplying it with the molar mass of CH4, and that comes out to be 16.042. Then we have to find the mass of water, 0.2 times, that is 18.016. So this comes out to be, now let's find out, For carbon monoxide, the answer is 5.602, and for this one the answer is 3.407, and for this one the answer is 3.208, and for this one the answer is 3.603 grams. So the answer, the greatest number of mass, is going to be A. Now, in order to find the next question, what we need to do, we are given with the moles, and in order to find the greatest number of atoms, what we just need to do, because we know that number of atoms have a formula is equal to mole times Avogadro's number. Okay, and like if we want to find out the number of atoms for P2O5, so we know for that purpose I just need to multiply how many number of atoms are in P2O5. So I have to multiply 7, because there are 2 phosphorus and 5 oxygen, so I have to multiply 7 with the mole and Avogadro's number. So what I'm going to do here, because Avogadro's numbers are same for everyone, so I'm just going to multiply with the number of atoms, like 7 here, with the number of moles. And like here, how many atoms are there? Copper is 1, 2, 6. 6 plus hydrogen is 10 there, so it would become 16. 16 plus 5 oxygen, so there are going to be 21 atoms, okay, in total, and I'm multiplying it with 0.3 there. Then for this ethanoic acid, I am multiplying 0.5 moles with the number of atoms, which are 1 plus 3 4 plus 1 5 plus 1 6, 6 plus 1, that is 7, plus 1, that is 8. So I am multiplying it with 8. And for this, 0.9 times 3, because there are 3 atoms in water. So the answer comes out to be 2.1. It comes out to be 8.4, and it comes out to be 4.0, and it comes out to be 2.7. So the one which is going to have the greatest number of atom is going to be copper sulfate dot 5H2O. Okay, so the right answer is going to be B. Moving towards the last question, and that is going to be, no, I think so, yes, this is the last question. So let's see about the last question there. Maybe, yeah, we have some more questions here as well. So the number of oxygen atoms we need to find out here in this one. So first we are given with the mass, so I'm going to find the moles here, which is equal to mass divided by molar mass, and that comes out to be 44. So the moles are here going to be 2. Okay, so in order to find the number of oxygen atoms, what I'm going to do, number of oxygen atom in carbon dioxide, so I'm going to multiply the moles times Avogadro's number, but here we have 2 oxygen atoms in 1 mole of carbon dioxide, so I have to multiply this with 2. So the final answer comes out to be 2.41 times 10 raised to power 24. So the right answer is going to be C. Then we are given with the mass of butane. So I'm going to find the mole. Mole is equal to mass over molar mass, but here mass is in kg. So first of all, I need to convert it into grams by multiplying it with 1000. So that's going to be, mass is going to be 13,000 grams, and butane is an alkane which has a formula C4H10, So it comes out to be how much? It comes out to be 4 times 12.01 plus that is 10 times 1.008. So mole comes out to be how much? Mole comes out to be that comes out to be, so first find out the moles here, and they comes out to be 13,000 divided by total is 58.12, and that is 223.675. Now what I'm going to do, I'm going to find the number of molecules, and the formula is going to be mole times Avogadro's number. Mole is 223.675 times 6.02 times 10 raised to power 23, and the final answer comes out to be 1.35 times 10 raised to power 26. That is going to be this one. Then the substance that contains the greatest number of moles is, so let's see which contains the greatest number of moles here. So first of all, we need to find the mole. So mole here is going to be mass, which is 3 gram, and divided by molar mass of ammonia, which is 17.034, and that comes out to be 0.18. For CH3Cl, mole is equal to mass, which is 3, divided by 50.484, and that comes out to be 0.06 moles. For H2S, it is going to be mole is equal to mass, which is 4, divided by 34.076, and that comes out to be 0.12 moles. And for HCl, we are going to have 3.50, which is the mass, divided by molar mass is 36.458. It comes out to be 0.10. So the final answer is going to be, the greatest number of moles is for this one, for ammonia. Final answer is A. Thank you so much for watching.